record on this computer. So let's take a peek at what you're handing in for module 3. So now that we've concluded and we've gotten through, if you would, the lecture/demo information, practice problem wise, I want to make sure that everybody's on the same page and knows what they're handing in for the practice problems and assignment number 3. So, practice problems. We did example 6.1 calculations only the last time we were together at the very beginning of class. And I need to update this. I'm so sorry. We're not going to do example 6.6 out of the book. We are just going to stick with our handout. So it's just, I'm going to just update this really quickly. I'll do that really quick. So example 6.1, which was calculations only, it was a hand calculation. It was the one where we had the box on the conveyor. Okay, it was the first example in the chapter. We did that together, working it out by hand. Then we moved to the handout. This is the handout where we filled in. So this is that 10-page handout that we just got done with. Okay. So at the beginning, there was, blanks to fill in, units. We did that together throughout. And then today we just finished up with those 2 relative velocity equations. You're handing that in, filled in with the things that we did. Additionally, the screenshots for the last 2 problems that we talked about. Okay. The relative velocity problems. And then I just want you to answer the 2 questions here, making sure that you have that in there. Now, you used AutoCAD for those last 2 problems. Make sure that you have your kinematic diagram identified. Show all of the appropriate labels. Show your vector equation identified. And then any vector work that you do, make sure that you have arrowheads and labels, all that kind of stuff, okay, that we've been talking about. And then make sure that you dimension your final answer. I don't want to see a note for your final answer. It has to be an actual dimension because that proves to me you drew it to scale and you have it. If you just do a note, then you can put anything in. You can type in whatever that answer is, okay? So I want to see the dimension, and that's why you have to then scale it large enough that I can see the actual value, okay? And then show all of your work. If you want to add that work as part of like typing it in with text in the AutoCAD file/screenshot, that's fine. Okay. So any questions at all about practice problems? So it's just 6.1 and the handout. Okay. So then let's look at assignment number 3. Sorry. Save. All right, let me go back out to the module. It's not letting me go backwards. So assignment number 3. Assignment number 3, we already started talking about. The last time that we were together, we said you can do everything through 6.12. And there was a mixture of calculations and unit conversions, and then and calculating. There was a roller conveyor at the very end with the last 2 problems, 11 and 12. And we talked about that a little bit at the end of our last lecture. Okay. But that was kind of like the first portion of our handout. The last 4 problems now are going to be the relative velocity stuff that we looked at today. Okay. So let's take a peek at the end of our chapter and make sure that we have a good understanding of what we're going to be doing. So on page 162, the first problem that you're assigned is 621. 621 is referring to the reciprocating saw down here. You've seen this mechanism before. And what you want to do is you want to use the relative velocity method to graphically determine the linear velocity of the blade. So the blade is out here, okay? If you set it up just like we did with the numbering, which I encourage you to do, that's going to be the velocity of point C, right? It's just like the second to last problem we did in our handout. Oriented a little bit different, but it's a slider crank. This is the process that you're going to go through. Okay. So it gives you the information that the crank over here, this is the crank wheel, but we represent it with just the radius going to, as we've seen in the past. It's going to be going counterclockwise at 1500 RPMs. Okay. And you want to calculate what is the velocity of that blade. It's going to be the velocity of C. There's no W4 in this one because your output link is a slider. So it's just like that second to last relative velocity problem that we just did. Okay, slider crank. So that's your first one. The second one that you're going to do is going to be another slider crank. Okay, so we've seen this shearing mechanism before. Use the relative velocity method to determine graphically the linear velocity of the blade as the crank rotates from where it's at right now in a clockwise direction, 100 RPMs. Okay, this way. So it's rotating up 100 RPMs. Then what's happening down here? That's another slider crank mechanism like the second to last problem and the previous problem that we just looked at. So you want to look at this one as guidance. Okay. Your next one is going to be number 28. 28 uses this illustration right above. So using that very same illustration that we did for 627, our last practice problem, you can use that same kinematic diagram. Okay, but this time at the top of the next column, we want to find out what that water bath is doing, angular velocity of our water bath, which was the same link number 4, as the crank this time rotates clockwise at 75 RPMs. The last time it was going counterclockwise at 100. This time we're just changing the direction, but it's the same problem. It's the same problem as this one, exactly the same kinematic diagram, but this time we're going clockwise at 75 RPMs. Okay, so what is W4? So exact same problem here, just different numbers. Okay, the kinematic diagram remains the same, so that's going to be a copy paste for you. All right, and then the last problem that you have assigned is number 31. Now, if you're not listening to me right now, come back to me, okay? Because I'm changing this problem slightly. So do I have everybody's attention? Okay. So for number 31, for the hand-operated shear, as we see below, use the relative velocity method to graphically determine the angular velocity of the handle that's required to have the blade cut through the material at a rate of 3 millimeters per second. This is an opposite direction, okay? So what it's saying is we've got this blade here. This is going to be moving down because it says it's cutting, okay? It's cutting, so that means it's moving down at 3 millimeters per second. So we know the velocity C. C this time is going to be our known. We're going to use the relative velocity method to graphically determine what is W2 have to be in order to do that. Okay, so this is kind of, I don't know, I think maybe a more practical problem where we're looking at, here's the final result I need, 3 millimeters per second going down. What has to happen at the handle? Okay. So this one is a W2. Okay, this one's going to be a W2 that you're going to be solving for, knowing the slider. Okay. Now, notice that I crossed out the end here. It says also determine the linear velocity of point X. Cross that off. Cross that off. Okay. I also have that as a note on the assignment. Okay. So you'll see here that only solve for W2 for number 31, not X. Okay. So just the first part of that problem. Now you're going to notice that you do have an answer key. Okay, so if you look at the answer key here, these are going to be your final values. Okay, I gave you some intermittence along the way, like for instance, for problem 21, it just wants to know what is the velocity of C, which is that slider. But I gave you also the velocity of B. You have to calculate velocity of B. You have to show me the work, but this way at least you know you're on the right track. It's one of those intermittent. So your final answer is whatever the problem is asking for. And I gave you a couple, if you would, intermittent steps along the way so you knew you were on the right track. Because these problems get pretty long. And you don't want to get all the way to the end and be like, crap, I'm off. Now I got to go back and figure out where. At least if you know that you get this, you know, VB along the way early on, that's okay. All right. Okay, so questions on either the practice problems or the assignment number 3. Okay. So then, I'm going to stop this recording here.